So what we did in exercise 1 was actually a uniform distribution. So you have another example of that here. A random variable follows a uniform distribution. All you need to know about uniform is that it means it has an equally likely chance. So there were some people, I think, in previous discussion boards and whatnot who described distributions as being uniform. That very much means something in statistics. A uniform distribution is one that has an equally likely outcome. So that curve is just a straight curve. So this is what you should have seen with our random numbers when we actually selected them. It didn't work out that way because we're not good random number generators. But that's what a uniform distribution should look like. Suppose that time to complete a question has a uniform distribution between 0 and 5 minutes. What is the probability of a student selected at random taking between 1 and 2 minutes to complete the question? So, if we wanted to visualize this, we can draw our curve like we did on the last problem. X is going to be the amount of time to complete a question. And they've told us that it's uniform between 0 and 5 minutes. So equally likely all the way across from 0 to 5. After 5 minutes, the probability drops to 0. Before 0 minutes, probability drops to 0. So this is our curve. We don't necessarily know the height of this probability density function, but we can figure that out just like we did on the last example, right? We know that the entire area of this whole curve needs to be 1. And we also know that the area of a rectangle, because that's what we're going to deal with anytime we're dealing with a uniform distribution, is the base, or the length, which is going to be 5, times our height, which we don't know. So this is going to be 5 times our height, which means that our height is going to be 0.2. So we actually can see exactly what that value is going to be. And then we can go back to the question. We're looking for a probability that that outcome, that x, is between 1 and 2.2 minutes. So if we wanted to draw that on our curve, there's 1, 2.2, and we're interested in this area, which again, we could either do as the proportion of the curve that we've shaded or just by doing our area of a rectangle, which is our base. The base now that we're looking at this other section is 1.2. And our height, same as what we got from the last one, that hasn't changed, 0.2. So we get 0.24 as our area. So these questions I like to put on the exam, and you'll see them also on your discussion boards. Not discussion board, your knowledge check. The big thing here is they're either going to come down to, area of a rectangle or area of a triangle. Because I'm not going to expect you to have anything else crazier than that in terms of your geometry. So most of the time you're doing area is length times width for a rectangle, or if we're dealing with a triangle, 1/2 base times height. And it's all about what you shaded. So those questions, students tend to struggle with them a bit, but if you draw your picture and you shade and you just think about geometry, they're really not that terrible.